Hello boys and girls, welcome back to Mr. Nice Guy tutorial, and today we'll be looking at SolidThinking Inspire on design optimization. Okay, first thing first, get a 3D file. You can get your 3D file from GrabCAD, from free 3D model and other websites. So before you choose your product for this tutorial, there is few design consideration that you need to take note. First thing first is that the part should not be too thin, because otherwise solid thinking inspire will not optimize your product well. And secondly is that the product that you choose, you know what type of product that is, meaning to say that when you want to apply the force and the constraint later, you know where the force and constraint should be. This is important for the inspire to simulate or give you a design on what would be best for your optimization. So for this tutorial, I'll be using this product, which is a front axle of 4x4, I think buggy cart or small off-road vehicle. So from this is the original data that I get from the GrabCAD. So with this, going back to the design consideration, I know that my part is not too thin, and I know exactly where the forces should be. Should be the constraint, and forces will be acted upon this point few by the weight of the engine itself, by the weight of the spring, the tires, and the body itself. So I know where the force should be. So from this, we cannot use this finished product for Inspire, because this look already optimized, and further optimization will not benefit you well, because there will be no uh, no no drastic change on the design itself. So for the purpose of this study, you need to simplify your end product. What I mean by simplify is that you have to recreate back your own model in the simpler form. In the simpler form, I mean that it should be as simple as possible. If you don't understand, well, I have a model that already been simplified for you. Okay, this is the end result of the simplification itself. Okay, note that let's see a comparison side by side. Okay, wait a minute. Hmm. Okay, this is a side by side view, as you can see. Okay. The purpose of this simplification is uh, to allow Inspire to generate ideas for the design based on your forces, based on the constraint, and give you an idea on how it should look like. If you use the final product from GrabCAD, there will be no room for improvement. There will be no room for Inspire to optimize. So you have to draw back your model and make as close as possible to the original part, and then you have to slice off, which means to isolate the part where the forces react. What I mean by this is that, see here, this is one part and this is another part, which if if you want to know if your split, not splice, split, if your split is a success, when you hide a portion of your product, you will see the part is isolated from other component. Okay, so this is the basic part on the SolidWorks. I don't think I have to give you a tutorial on how to make a model itself. So just a basic split tutorial is just go to sketch the area that you want to split off. Let's say this part, then make a circle, exit the sketch, and then go to direct editing and split. Okay, split. So we should click. Okay, the split, the trim tool is the sketch, and the body, which part do you want to remove it from? So you can try it via cut bodies. So make sure that the default will be consume cut bodies, but you have to tick off, or else the cut will disappear. So when you cut the bodies, okay, you will see that the resulting body is here. Click auto assign name. It should be fine, and then click OK. Okay, that's it for the split. So after this, you can save it just as SolidWorks file, and then we can move on to the Inspire. So going to Inspire. Okay, here is your basic layout of Inspire. As you can see, we have geometry where you can edit later, structure, motion, and manufacture. Okay, go open up your save file from SolidWorks earlier, the simplified model, and find open up your file, which is simplified frame. Alright, this, when you open up your file, you will see that there is an overlapping body of the first one. Usually the imported CAD model you take from GrabCAD. Just hide it or just delete it. Okay, this should be the, you should have plenty of simplified your file name body within Inspire. Right click to start the analysis, optimization. Right click on the part that you want to optimize and click design space. Okay, depending on the number of your design space, you can do it more times as needed. Okay, as you can see, the split part is on gray color, which is for the optimization. The gray part will not take place. This is the gray part is where you should put your fastener, your joint, or your forces. So for this simplified model, I would just use fastener to hold my part. It can be ground bolt, whatever you choose. Okay, so next, go to load and forces. The direction of force is depend on how much you know your product. So for this product, I know that this hole here, and here supporting the engine weight. So I know the engine is roughly around 151 kilogram times by 10 to the gravity acceleration. It should give roughly around 1500 Newton. So put my force here, 1500 Newton in the direction of Z. Okay, if you are not sure, you can pan around and make sure my forces is acted downward. So click again, it will change the sign. So I'll do the same for each part that I need. And that's about it. Oh, before the optimization, you can mess around with the setting here, whether let's say your shape is symmetry on the left and the right side. You can apply symmetry control and click symmetry. Then you will see select a design space. The maroon color is the design space, so click it. And which part of your product is symmetry to the other side? For me, it is left and the right, so I tick off the other part. So I know that my part is symmetry left and right, the same. So I can apply this, usually used for mold casting, and you can try it. So I try for my casting for two split draw upside, top side and down side. So I know this will affect your simulation as well. Your not simulation, your optimization as well, because Inspire will generate a design concept for you based on the data you provided to it. So once you're ready, you put all your forces and your constraint. You put the shape control as well. So you can just run the simulation by clicking on this tiny play button. Okay, so here you can see your parameter for the optimization. The only thing yet that you need to consider is the mass target. So for this tutorial, we wanted to reduce the mass of this product while maintaining the rigidity of this part. So before you run this optimization, you should probably analyze first. Analyze your current product, which part is the critical one, which doesn't is not critical. I have a sample of analysis that I've run. So this is the analysis for max tension and compression. This is the original part. So I know this is the critical part that needed most attention compared to other area. So from this, so I know where at least I have a rough idea on where my optimization should occur. So after you run the analysis, this can take up to a minute to 5 minutes depending on your computer, but optimization will take a lot longer depending on difficulty of your geometry. For this simulation alone, mine taken around 1 hour 20 minutes. So if you have a slower computer, it might take a lot longer. So my setting is done. So I just run my optimization, and after 1 hour later, I will have something that look like this. It is very ugly because this is what Inspire suggested from all the data that you provided, the force, the constraint, the symmetry control, and so on. So from this is not the final product. Inspire only give you a design idea. So the design part is for you to do it yourself. And it is very easy to do this. You can either go back to SolidWorks and manually edit your original simplified version of your model, or you can directly edit here in Inspire. Go to the geometry tab and you can use polynote for instance, and there is a couple of icon that seem weird at first, but trust me, it is easy to do this in Inspire, although it may take a bit while. So create meaning you will create a new a new, let's see first. When we click create, okay, we'll create this one big ball, and you can edit the ball as you see fit. At first I just change the thickness a bit to match my optimized data. This should look good at the center. And then I wanted to add some section to this by going to this split cage with loop. Okay, change it to top view by hovering on the axis, go to top. Okay, here you can manually split your ball your gray ball into finer detail. Okay, and okay, the shortcut for section without going to the button is just pressing your shift button and go to any end that you want. Okay, let's say I want to cut the mid section. Just shift and click. Shift and click. Okay, so you have a rough idea. So from this, you can remove any part that you don't want by clicking the negative button here, minus. So click here, you don't want this. Okay, you can go finer detail by pressing another shift and then shift some more, remove here. Oops. Okay, so you have a bit more detail later on. So after you have done probably around 6 to 10 hours of messing with the topology, you will have something that look like this. Okay, you can hide the optimized result. So for my product, this is my optimized result. This is after spending around 12 hours, 6 hour testing and 6 hours of finalized product. So this is what my final optimized result look like based on the mesh provided by the Inspire. The mesh is not the final aspect of your design, but you have to manually make your topology polynomial yourself. So my advice for working with polynomial is you start off with one polynomial. Let's try again. You start off with one big ass polynomials, and you create, let's say you want to make, oops, let's say you want to start with this side first. Okay, you can either go by create or wrap, whichever that seem the easiest for you. So you can click and it will just section off your mesh, and you can go from there. You can add more part. You can even section this off like to make another section go up, or you want to split some more. You want this one to go here, there. Okay, depending on your product or the level of your confidence, the polyneuts might have smaller sample size than you original intended. So watch out. This the smaller the element size, the harder this program will tackle your computer resources such as your RAM, your processor. So be mindful of that. The more detail that you make, the heavier the program will be. So that's about it. This is the optimize. Okay, this is the end result for my project. So be mindful of this mass. Okay, this is the total mass. Make sure you change your material into according what your final your actual product be. For me, I just use aluminium, and then my end product only weighed around 74 kilogram from my original, which is 139 kilogram something. So good luck, and I pray for the best of you. But before I forget, another side note to on working with polymer is that start with one component and propagate from that original part. Don't try to combine few polymer together because it is very hard to make a correct connection between polymers. Okay, keep that in mind, and I see you again. Goodbye.